right, so we are going to be simplifying trigonometric expressions today, which we've kind of done every day. But this is just learning a few more techniques. This is going to be lesson 5.1c. Simplifying trigonometric expressions. All right, so on example 1, our directions are to simplify. All right, and so for A, we have a fraction. The numerator is sine of x cosecant of x, and the denominator is tangent of x. Right. And we talked about this a little before, but one thing that you guys can remember that will save a lot of time and just help you do things a little faster is that when you multiply reciprocals, it is always going to equal 1. So I'm going to find somewhere to write that. Okay, so sine of x and cosine of x are reciprocals. So when I multiply those together, I know that's just going to be 1. All right, then I can use the identity number 6 and know that 1 over tangent of x is just going to be cotangent of x. All right, now let's look at B. For B, we have cotangent of negative theta times sine of theta. Now don't let the fact they're using a Greek letter as your variable on this make you confused. It's not a big deal. It's just like x or u or whatever. All right, so whenever we see this cotangent of negative theta, we need to look at the even and odd identities. And cotangent is an odd function. And so according to number 23, the cotangent of negative theta should just be the negative cotangent of theta. All right. Then we start looking at cotangent and sine. And like I've told you before, I would probably only take one of them and change it. In this case, it would be smarter to change cotangent. So look at what cotangent could equal. Cotangent could equal 1 over tangent according to number 6. And cotangent could equal cosine over sine according to number 8. And so for what we have in this problem, it's going to be wiser for us to change cotangent of theta to cosine of theta over sine of theta. Okay. And we are multiplying that by sine of theta, just bringing that down. Right? And then what happens to the sine of theta is they're going to cancel out, and we're just going to be left with the negative cosine of theta. And that is the answer. That is the most simplified form. All right. For C, we have tangent of x times the quantity cotangent of x plus tangent of x. All right. So what we're going to do is the distributive property. So we're going to distribute this tangent of x. So I'm going to multiply tangent of x times cotangent of x. So what happens when you multiply reciprocals? When you multiply reciprocals, it always equals 1. So tangent of x times cotangent of x is just 1 when you multiply those together. All right, and then I'm going to multiply tangent of x times tangent of x. That's going to give you tangent squared of x. All right, and then whenever you have a 1 and a squared trig ratio, we always look at the Pythagorean identities. So 1 plus tangent squared of x, that is going to be number 10, and that's just going to be secant squared of x. Right, and that's it. That's as simplified as it can go. Okay, now this last one is kind of a doozy. So if you're at the bottom of your page, you're probably going to want to flip over and start this on the back. So what we have is cosecant of x minus cosine of x cotangent of x. All right, so I'm just going to start off just changing one thing out of those. All right, and in the end, we're going to probably change a lot of them, but we're just going to start off slow. So you just look at what you have. Cotangent has the most options. So we can change cotangent to 1 over tangent or cosine over sine. So that's what I'm going to do. I'm going to leave. I'm going to leave cosecant of x alone for now, cosine of x alone for now, but change cotangent to cosine of x over sine of x. Okay, now nothing cancels there. I can multiply those cosines together and get cosine squared. All right. So start looking at cosecant. I could change cosecant of x to 1 over sine of x. And that would actually be really helpful because I'm going to have to subtract these fractions. And this one already has a denominator of sine. So if I change cosecant to 1 over sine of x, I have a common denominator, which is awesome. It's one less thing I have to worry about. All right. So since these have a common denominator, I'm going to go ahead and make this one fraction with the common denominator as the denominator. The numerator, I can't really combine those, so I would just write it as 1 minus cosine squared of x. All right, and then whenever you see a 1 and a squared trig function, you're probably going to use a Pythagorean identity, 9 through 11. All right, the one that has 1 and cosine squared is number 9. All right, but we want the 1 and the cosine squared on the same side. So what you would do is subtract the cosine squared of u. So that would mean that sine squared of u is equal to 1 minus cosine squared of u. So in the place of that, 1 minus cosine squared, I am going to change that to sine squared of x. The denominator, I'm just going to leave alone. All right, and then if I have sine squared of x and I divide that by sine of x, sine is going to cancel out, so that just leaves you with sine of x. All right, now if that doesn't make sense to you, remember that sine squared is sine times sine. All right, and then what happens is a sine of x cancels out. And so that just leaves you with sine of x on the numerator. All right, so what I want you guys to do for your assignment is still on page 355. I want you to do 35 through 44.